Hey, happy math class. Let's get straight to work. This is the notes that I really want you to focus on today. We're solving radical equations, which might include some square roots or cube roots, etc. So we have to keep that in mind. So let's keep this in mind too. We have radicals that can be exponents. It's kind of our choice how you want to write those. If you like exponents instead of a cube root, use the 1/3 power. Use the 1/2 power instead of a square root if you want. And you know how it goes all the way up the chain here. Exponents and radicals are related. But check out the directions they give you here. Read them carefully. You can pause the video if you want. We want the radical alone. And we're going to raise an exponent on each side to eliminate the radical. And then we're going to solve. And occasionally, we have an extraneous answer. Maybe you plug your solution back in, and you get the square root of 16 equals -4. And so we know that's not going to work out. So using number 1, let's do exactly what they say. Subtract 5. And then get rid of that radical. So we're going to raise both sides to the 2 power. This could have been the 1/2 power, and we raised it to the 2/1 power. However you want to look at it. Okay, and when I check this answer, I think we're good. The square root of 49 is 7, and 7 plus 5 is 12. So we're golden. Done. Trying number 2. Well, we don't have that radical alone. So I'm going to subtract 3 and get rid of this negative. I'm going to divide by a -1 so I can get a nice radical as isolated as possible. Now, to get rid of this radical, you see they say raise it to the power of the index. Yeah, that's called the index of 4. So we could raise it to the 4th power. Okay, but you know it also means m to the 1/4 power, and reciprocal of 1/4 is 4. So either way, we're going to take both sides in their entirety to the 4th power. If that was a -3, we would include the negative in the grouping. And they're going to undo each other, and we're simply going to get 81. Okay, so as I look at this, I would have to use a calculator and say, what is the 4th root of 81? What is 81 to the 1/4 power? And it would say 3, and 3 minus 3 is 0. So we're golden. Okay, now let's get to some that kind of rock the boat a little bit. Number 4 is going to rock the boat. We want to get rid of that radical. I'm going to subtract 10. And then I'm going to get rid of the radical the best I can. To get rid of a square root, we raise both sides to the 2 power. Okay, as I do that, I get a very simple 2-step equation. I'm going to add 5, and I'm going to divide by 6. I think my answer is looking pretty good. But when I plug it back in, I get the square root of 6 times 9 minus 5. That's 7. And 7 plus 10 is not 3. So you guessed it. That's an extraneous answer. And our final answer is there isn't. There isn't a solution to number 4. It is absolutely no solution. Okay, now take a moment now to pause the video and look over the notes again. Do you need to rewatch anything? Take a moment. All right, we're back. We're going to number 5 because we're seeing something besides a radical. It means a square root. but we've got to isolate it. We've got to get rid of anything possible with the exception of the exponent term. And we're done. We've gotten rid of the -9, nothing but exponent term left. So I have an option here. This means square root, or I can just raise both sides to the reciprocal. Obviously, 2 over 1 is just 2. And so this is going to give me 4 squared, or 16. And these two things are going to become an exponent of 2 over 2, or 1. And we usually don't write down the exponent of 1. But it is a simple equation now. Adding 12 to both sides. I can check it out, see what works. I could plug the 28 back in. I get 16 to the 1/2, which is 4. 4 times -9 is -36. That checks. We are good. And we are moving on. Okay, number 7, a little uglier. Ugh, definitely a little uglier. We want that radical alone. So that 4th root of 8k plus 12, I'm going to add 9 to both sides. Now to get rid of the 4th root, we're going to raise it to the 4th power. Just like it said in number 2 above our notes for the directions. Raise each side to the power of the index. Well, that was an index of 4 or an exponent of 1/4. When flipped is 4. So when we check this out, we're going to get a 2-step equation left over. Remember, this is not -2 to the 4th. This is the quantity of -2 to the 4th. That's going to be a positive number. So it's very important to consider using a parentheses when you raise a power with a negative there. Take 12 away. Let's see. We are down to 1/2. Okay, and it looks really good. We are all set to go, and it looks pretty. But guess what? When I put that 1/2 in here, I'm going to get 4 plus 12, or 16, right? And 16 has a 4th root of 2. 2 minus 9 is not -11. It happened again. An extraneous solution. So we're left with no solution there. Okay, pause it for a minute and see how you're doing. Hey, flip over your notes. Number 9 seems pretty simple. It looks to me like they both have a radical, a square root. So we just have to square both sides. And the radical is gone. And we can do a little solving. Add 2u to both sides. Add 8 to both sides. It's a pretty simple equation for us algebra 2ers. And we get a nice solution. I'm going to check that. Let's see, that would give me the square root of 9 if I plugged in the 17. That's going to be 3. And 43 minus 34 is 9. Square root of 9 is 3. It checks. That is a good solution in number 9. Now let's get to some that might throw you for a loop. Number 12 might bother you a little. It's a little different than what we've done. We can't isolate the radical. It's kind of stuck with a -2 coefficient there. And so I've got no other option, as far as I see, than to raise both sides to the index. Or this is like a 1/3 power, raise it to the reciprocal. Okay, now I think there's going to be some issues here because we have to raise the radical to the 3, but we also have to raise that negative 2 to the 3. And that's where we're going to lose some accuracy if people aren't careful. What is a negative 2 in a quantity to the 3rd power? That's negative 8. And the cube root and the 3 power cancel out the radical, and you're left with an n being multiplied next to that negative 8. So let's see, what do you say we add 10n to both sides, divide by 2, and we get 7. Now on a calculator, I think I would plug in the 7 and I would check this out and make sure it works. It will. It is true. So we can check off number 12 and see if there's anything else we have to be careful about. 15 shows something a little different. Take a look. Ooh, the quadratic has infested our notes here. Getting rid of this square root, it's by itself. To undo a square root, we raise it to the 2 power. Now this is where we're going to lose a lot of students. They're going to say, that's m squared plus 25. No, that's m minus 5 and another m minus 5. There's an inside and outside. It's a double distributive. It'll end up giving us this by the time we simplify. M squared minus 10m plus 25. So this is a quadratic now. I think I'm going to have to move everything over there and see what happens. I'm going to subtract 6m, and I'm going to add 38. Ugh. Lucky for me, when I think of 63, I think of 7 times 9, and a 7 and a 9 can make 16. But would you get the signs right? Would you get the signs right? Now we have to solve each factor equal to 0. That's how we handle solving a quadratic. What makes the multiplier 0 so that they'll multiply to 0? And we get 2 answers, both 7 and 9. Using a calculator, I plugged it in, took the square root, etc. They both worked. So I'm good. I'm feeling sassy. And these things tend to go pretty well for us. Now, I can't think of anything that I would really need to show you now, except perhaps 13. We won't finish it, but just in case you were wondering, squaring both sides would have given you this. And I think it might be a blast from the past to factor this equal to 0. We would definitely need a distributive property. Okay, and a number 13, when I check 0 and when I check 8, they work just fine. Okay, last problem of the day. I'm going to give you just a little warning. Number 16, I bet you there will be extraneous involved. Just I have a hunch. So pause the video, do the problem, and then check back here. Aha, I was wrong. It had a repetitive solution. By the time I got everything over there, it was a simple quadratic, and I got the same solution twice. So checking the -1 back into here, it worked. So I know I'm right. Okay, now let's make a pact here. Let's try some of these problems in the classwork. All right, I really want you to do a good job with it and make sure you're catching on. I don't want this time when I'm gone to be wasted. So give it your best shot. Let's get something done.